Okay, question 8. So figure 8.1 shows an apparatus used when some students investigated what happens to solid substance R. So this is a solid. Okay, so sorry, let's label here this initially solid. The solid is contained in a metal can, so this is a metal can. So metal can. It is heated by an immersion heater. So there's an immersion heater over here that heats up the solid R. Now, the student measures the temperature of substance R at a regular time interval. Figure 8.2 shows the graph they plotted from their results. So we do know that the temperature increased until it reached about, over here is about 70. Okay, then the temperature remains constant. Then the temperature went back up again. So describe what is happening to substance R in region X, region Y, and in region Z. So at region region X, okay, the solid temperature is increasing, okay, and the particles are vibrating more vigorously. Okay, do take note the particles vibrating more vigorously part is not really required because it did not say using the kinetic model of matter. So I'm just writing there just a little bit more explanation here. So the solid's temperature is increasing at region Y. Okay, the solid is melting at 70 degrees Celsius to form a liquid. Okay, so actually what's happening here is that the particles are being spaced further apart from very closely packed to become closely packed. And lastly, at region Z, okay, the solid has completely melted at 27.5 minutes, and the liquid temperature is increasing. So when temperature of the liquid is increasing, the particles are moving around the liquid at a faster speed. Okay, so that's for part A. B part 1, the immersion heater has a power of 50 watts. So 50 watts here is the power. Use this information and figure 8.2 to calculate the energy output of the heater in region Y. Okay, so in region Y, so we do know that at 7.5 minute all the way to 27.5 minute. Okay. Um, so calculate the energy output in region Y. So we know power equals to energy over time. Power is 50. Energy you want to calculate. The time taken for region Y actually is 20 minutes, but we need to convert it to seconds. So do remember, energy was because we're using power formula, the time must always be converted to seconds. So 50 multiplied by 20 multiplied by 60, this is equals to the amount of energy. So if you were to press your calculator, okay, so energy will be equals to 60,000 joules. 60,000 joules. Next part, explain why the energy gained by substance R in region Y is less than calculated in B part 1. So B part 1, we know that this is the energy output, but they say that it is less than whatever is calculated in, we know the energy output is 60,000, but we know that the energy gained by substance R is actually less than 60,000 joules. So how do I explain this? It says that most probably in this case, energy is lost to the metal can, okay, as its temperature is also increasing. So as the metal, you see, as you heat up substance X, the metal can is also part of the whole setup. So the metal can temperature will also be increasing. So imagine as you supply heat to substance R gain heat, the metal can itself will also gain heat. So not all 60,000 joules of energy will go to substance R. Part of it will go to the metal can. Okay, so do take note of that. Now the part C is just a totally separate question. Okay, still on the thermal properties of matter, but it's just purely on evaporation and boiling. So I'm just gonna write down three differences. So first thing, boiling occurs at a fixed temperature, okay, while evaporation occurs at any temperature, okay, occurs at any temperature. So do take note, you need comparative term. So while you need it there. Next one, um, for boiling, okay, the temperature remains constant while while for evaporation, the temperature may change. Okay, so in case you forgot, actually when you have evaporation, it actually causes cooling. So the temperature of substance will actually drop. Last one, boiling is relatively fast as it occurs throughout the liquid. Okay, while evaporation is relatively slow as it occurs, as it occurs only at the surface of the liquid. Okay, so this is for question 8.